So for this second example, we're going to be using the vertex formula again to calculate Calcu-Cola costs and graph the daily cost function. So let's buckle in. It's going to be a good ride. So, as you remember, Calcu-Cola manufactures math-enriched soft drinks that has wisdom of famous mathematicians in every sip. And their daily production costs are given by this function. And we want to find the vertex. So the input coordinate for the vertex, or in this case, it's the units, is always going to be minus b over 2a. So taking the b as negative 118 and taking the opposite of that, you're going to get positive 118. The a is 0.52 and doubling that gives you 1.04. And dividing those out, I'm getting approximately 113.5. And we'll put, these are the units, however many units they sell. And always to find the output for the vertex, the y in general, or in this case, it's going to be the cost, c, we're just going to take this input of 113.5 and plug it into your cost function. So 69,000 minus 118 times 113.5, and then plus 0.52 times the 113.5 squared, and pop that into your calculator and get a value. So after doing that, I'm getting a cost of $62,305.77. And in this case, because the a of 0.52 is positive, this means that the parabola opens upward and the vertex is a minimum point. So I'm going to say if 113.5 units are produced on a particular day, then the minimum cost is this $62,305.77. That's the smallest the cost is going to be. So that also will help me set up my window. So let's go down to the graph and put that on. So your vertex is 113.5 for the U and 62,305.77 for the cost. And that's the minimum. So I got to get this 62,000 number on my graph at the bottom, at the minimum. So what I did was, instead of starting at 0 like we normally do, I wanted to start my graph at 60,000 and go above that. And this little dashed line, double dashed line in there means that we're skipping scale values. I'm not putting all the scale values starting at 0. We're going to skip a bunch of them and start at 60,000. Also, the U of 113.5, I want to have in the middle of my graph. So if I take 113 in the middle and double that, that's going to be about 226. So I need to have that point. So I need to go at least out to 226, and we went out a little bit further. But you want to use these numbers to plan your window so that you can go at 113.5. So roughly about right here. So we're going to put our line of symmetry in the middle of the graph at the 113.5 approximately, and at 62,000, which is roughly going to be about right here, I'm going to put this minimum value and label that. So 113.5 and 62,305.77 is the minimum point on the graph. So then we want to find the u-intercepts and the c-intercepts to help us graph the function. To find the u-intercepts, you're going to let your c be 0. So plugging 0 into the left side of the function, you have 0 equals 69,000 minus 118u plus 0.52u squared. And then using the quadratic formula, I can try to solve that for u by taking the opposite of b, plus or minus the square root of b squared, minus 4. The a is 0.52, right? Your a, your b, your c. So the a is 0.52, and the c is 69,000. And then that whole thing is divided by 2 times a. 2 times 0.52, again, is 1.04. And just as we've done before, we're going to simplify the inside part before anything else. So I'm calculating 118 squared minus 4 times 0.52 times 69,000 gives me a negative 129,596 on the inside. And as always, the negative inside the square root is going to come out as an I, and we're going to switch the negative to a positive. And this means that there's no u-intercepts. And that kind of makes sense. The total cost is never going to be $0. So if we go back to our graph, unfortunately, we're going to have to say that there's no u-intercepts. And unfortunately, that does away with 2 of our key points to plot. And, looking at the graph, if this is a minimum and the graph increases from there, yeah, of course it's not going to have a u-intercept. It's not going to get anywhere close to the u-axis. So that's just going to put a more important significance on the c-intercept. So for my c-intercept, I'm going to let the units be 0 and calculate the cost of 0 units. And plugging 0 into the function, 69,000 plus 118 times 0 plus 0.52 times 0 squared is just going to give me 69,000. So the cost of producing 0 units, and this, as we've talked about before, this would be like the rent of the facility, any other costs that don't depend on the number of units they produce. So the cost of 0 units is $69,000. So $69,000 is our c-intercept. And that's going to be right about here. Now, what I want to do here is I really would like to have a third point, but I don't want to plot a random point. So what I'm going to do is this line through the middle of the graph, through the vertex, is called the axis of symmetry for a reason. And that's because every point on the left has a mirror image the same number of units away on the right. So if I look at this graph, and I notice that the y-intercept is 113.5 units to the left of the vertex, there's going to be another point to the right of the vertex at the same height. So if I go 113.5 units to the right, which puts me over at 227, somewhere around right here. And we're going to have that same height of 69,000. So I get this extra free point solely based upon the symmetry of the graph. Right? And then we're just going to try to sketch that graph as best we can through those points. So there you have a pretty good looking graph of your function 0.52u squared minus 118u plus 69,000. And now we can use this graph to do the review problems that follow. So again, please refer to your PDF notes for the complete solutions to the review problems that follow. So this section shows you how to use the vertex formula to find the vertex and get a good looking graph of a quadratic function. I'll see you in the next section. Have a good day.